Hi to all. In this session, we'll see experiment 8 SR latch, right? SR latch, layout of SR latch, right? SR latch using NAND, right? Is a SR latch connections, NAND connection by using two NANDs. We design a SR latch by using NAND gate, right? See, S equal to 0 or equal to 0, right? See, S equal to 0 or equal to 0, it acts as invalid state. Why it is invalid state, we'll see later, right? 0, 1, it acts as a set. S means set or means reset. Set, reset, right? Set, reset. 1, 0, it acts as a reset. It acts as a reset. 1, 1. 1, 1 means it acts as a no change state or memory state. No change state or memory state. Right? See, first we apply S equal to 0 or equal to 1. Output we get 1 Q equal to 1 Q bar equal to 0, right? Q bar. After S equal to 0 or equal to 1, we apply S equal to 0 or equal to 1. You get same output. That is nothing but no change. No change or memory element. Memory means it's capable to store. Capable to store previous value, right? It's capable to store previous value. It stores previous value. 1 0 1 0, right? After that we apply 1 0, you get 0 1 0 1, that is nothing but reset, right? 0 1. After that, after S equal to 1 or equal to 0, we apply S equal to 1 or equal to 1, you get same thing, that is nothing but 0 1, right? This is no change state or memory state, right? Next we apply 0 0, you get Q equal to 1, Q bar equal to 1, no problem. No need to complement, just okay, no problem. Q equal to 1, Q bar equal to 1, no problem. Next 1 1, give 1 1, it's not able to store previous value. 1 0, you get 1 0 or 0 1, not 1 1. That's why 0 0 acts as a invalid state. That's why SR acts as a S equal to 0 or equal to 0 acts as a invalid state. That's why when you give 1 1, it's not able to store 1 1. That's why it's a invalid state 0 0, right? See operation. S equal to 0 or equal to 1. Any one input is 0, output is high. Clear, right? Any one input is 0, output is 1. 1 1 1 1 0. Okay, case over. Next apply 1 1 1 1 1 1 0 1 0 1 means 1, right? 1 1 0, same previous value it stores. 1 1, it's after 0 1, you give S equal to 0 or equal to 1, you store same previous value. Okay, it's correct, right? Next S equal to 1 or equal to 0. After S equal to 1, S or equal to 0 or equal to 0 means any one input is low, output is high in AND gate, right? High. 1 1 0, right? Over this case over. Next apply S equal to 1 or equal to 1, right? 1 1 0, right? 0 1 1, right? Same previous values, stores same previous value, right? This case okay. Next see, S equal to 0 or equal to 0, any one input is low, output is high. Here also high, here also high, no problem. Next we apply S equal to 1 or equal to 1, right? S equal to 1 or equal to 1. See, 1 1, first this gate is reacts, you get 1 equal to 1, 1 1 1 1, you get 0 0 1 1. Otherwise first this gate reacts, you get 1 0 1 1 1 0, right? It is not able to store previous value 1 1. It stores either 0 1 or 1 0. That's why it 0 0 treated as invalid case, right? See this. Let's see how to draw this. SR latch by using LT Spy software, right? Go to LT Spice, File, New Schematic, Save as, so same VLSL app folder, SR latch, right? SR.asc, right? Next, go to component icon, select your library, your folder. By using two NANDs, we design a SR latch by using two NANDs, right? Right. By using wire, connect VDD, connect VDDs as well as VSSs, right? VDD, VSS as per circuit diagram. See, this be connected to Y feedback, this A connected to this Y as per circuit diagram, right? Next, we need 6 pins, right? Go to label net. Yes, it's also input. Yes. Next, go to label net. R also input, right? Input. Next, escape. VDD also input, right? Next, go to label net. VSS also input, right? Over. Next, go to label net. Q output. This is a Q. Next, go to label net. Q bar also output, right? Both two outputs, right? Q and Q bar. By using wire, yes, connect to A, or connected to B, right? Next, go to wire, Y to Q, right? Same Y to Q bar, right? Over. The schematic over, right? Schematic over. The schematic. Next, go to new symbol, save as SR, same VLSI lab folder only, right? Right here, draw one rectangle, right? Go to edit, press P, S, two inputs S and R, S, press P, R, same left side, place here, press P, VDD top, place here, press P, VSS at bottom, place here, right? Press P, Q, right side. Next, press P, Q bar at also right side, right? Right. Next, save, draw line, right, go to draw line, right, go to draw line, right, go to draw line, escape, to draw line, right, escape, draw line, right, right, see, right, this is symbol over, right, SR symbol, right. In next session we'll see test circuit as well as simulation, right. Thank you all.